Okay, we are solving systems of equations by graphing specifically. Now, in order to graph, we should remember that we have to solve for y. We need to get into slope-intercept form or point-slope form. So a system of equations is when we have two or more equations and we have to find two or more different variables. So I'm going to go ahead and get this started, and we'll solve for y by subtracting 2x here. So we get negative 2x plus 4. And right here we'll subtract x, and we get y equals negative x plus 8 for this second one. And then we're going to go ahead and graph both of these lines at the same time. So where the lines meet should be the answer. So the first one starts at 4, and I have a slope of down to right 1, down to right 1. And I'll get plenty of points here. And we'll go ahead and connect those. And neatness is going to be very important for the graphing method because you're really just getting an estimate. So any slight miss of a point or ruler could throw off your answer. So the second one starts at y-intercept 8, 5, 6, 7, 8. And this one goes down 1, right 1. And I can see that as I go left to right, that the lines are actually getting further apart. But that doesn't mean that I don't have an answer. In fact, here's my answer right here, where these lines are eventually going to meet. So, draw this line. Now the question is, well, what is this point right here? So wherever the lines intersect, they intersect right here, and that's where the answer is. So I have the point, this is negative 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have the point negative 4, 12 as my answer, or my estimated answer. And it may be that I want to find out if this is actually the answer. And in order to do that, I'm going to substitute back into this. So I'll have 2 times negative 4 plus 12, and I'm asking, does that equal 4? And if it does, then maybe I have the right answer. Negative 8 plus 12, well, that is 4. So that one checks out. But don't be deceived, just because it works in the first one doesn't mean it works in the second one. So I'll check the second one as well. So replace y with 12, replace x with negative 4. And does 12 minus 4 equal 8, I'm asking, and yes it does. So if it works, it has to work in both of them, and then it is indeed the answer. So we have done this one correct. Now there are 3 different types of systems that we should be aware of. The first being a consistent system. And a consistent system is when what just happened happens. And that's when the 2 lines meet and I get an answer. And that's called a consistent system. It means we actually have an answer. And these lines are 2 different lines, so that means it's independent. Another situation that could come up is if the lines never met. So something like this, if the lines were parallel, and they're parallel if they had the same slope. And if this happens, this is an inconsistent system, so meaning I do not have an answer. So it'd say no solution for this situation right here. Wish that didn't do that, but whatever. And this is also independent because I have 2 different lines. That's what that independent means, that we're having 2 different lines. I don't know why it does it right there, but whatever. Okay, so the last situation is when you graph one of the lines, and then when you graph the other one, it's right on top of it. They're exactly the same line. So I not only have the same slope, but I have the same y-intercept. And this is actually a consistent system because we get infinite answers, but it's a dependent system because it's really just the same line. So we aren't actually able to get a single answer for x. Okay, so let's try a couple others. So we're going to solve this system. It's already in slope-intercept form. So we have the point negative 7 for our y-intercept. So 1, 2, 3, 4, 5, 6, 7. up, but that is a positive 7, so I want to go down 1, 2, 3, 4, 5, 6, 7. Okay, well, I'm on the wrong slide. 1, 2, 3, 4, 5, 6, 7. Try one more. And then I have a slope of positive 2. So that means up 2, right 2. Always graph left to right, just like before. And this other one has a y-intercept of 1. So I want to make sure I draw this line out. Okay. And the other one, y-intercept of 1. And the slope of 1. So if it's not written, this is a 1 right here. And that's going up slower. I want to see where these meet, if anywhere. And it looks like they're going to meet right here. But I will finish off the line. And yeah, they meet right there. And what is that point? 1, 2, 3, 4, 5, 6, 7, 8. Looks like 8. And I think that's 9 right there. So we have the point 8, 9. So I think that is the answer. Now, if I wanted to check this answer, what would I do? Well, I'd put it in for x and y over here. So y is 9, and then 2 times 8, and I'm asking, does that equal 9? I do have some mess right here with this, and then 9 equals 9, so it checks. Got to check the other one. So does 9 equal 8 plus 1? I'm asking, and yeah, absolutely it does. Okay, so we can go on from that one. Our answer is indeed 8, 9. Now remember, when you're writing your answer, it is a point, and we do x, comma, y. Always put the x coordinate first. Now it's possible that you're solving for like a and b, in which case they go in alphabetical order, so a and b. Let's try another one. Now this time, neither of these are in slope-intercept form, so what do I have to do? Solve for y. And then I will be able to graph them. So I'll solve this one. So I'll put it over here. We will add the 2x. So that gives me 3y equals 2x plus 9. And I'll divide by 3. And when I divide, I want to remember that this divides everything. So y equals 2/3 x plus 3. So that's my first equation. And then this other one, so I have 4x minus 3y equals 9. I will subtract the 4x in order to solve for y. This will make it so that I can graph it. Don't lose this negative. And we have negative 4x plus 9. We'll divide by negative 3. And make sure we divide everything by negative 3. So a negative 4 divided a negative 3 is a positive 4/3. And then 9 divided by negative 3 is negative 3. So now I'm able to graph this one and this one. Those aren't my answers, but they'll hopefully lead me to the answer. So the first one has a y-intercept of 3 and a slope of 2/3, so up to right 3. And always graph left to right first, and then you can reverse it if necessary. It's not really necessary here, but I did it anyway. And we'll graph the other one. Has a y-intercept of negative 3 and a slope of 4/3. That means up 4, right 3. Okay, got enough points, and go ahead and connect. Sometimes it doesn't come out exact, and that's okay. We're just getting estimates, so this is our answer. And I'm pretty sure that that is the point 9, 9. And if I wanted to check, I would put it into both these equations. And if it doesn't work in one of them, that means that it is not actually an answer. Okay, now I have yet another one. Again, I'm going to have to solve for y. So this one, I'll just solve for y up here. And I'm going to subtract the 2x, so I have negative y equals negative 2x minus 1. And I'll multiply by a negative, so I get y equals 2x plus 1. This one, I will subtract the 5x, so I get 2y equals negative 5x plus 16. Then I'll divide by 2, everything divided by 2. And sorry about that little, something must be wrong with the board right there. Alright, so I graph both of these then. So I have a y-intercept of 1 and a slope of 2. There's my first line. And then my second line, I guess I'll finish off this one. Okay, that looks good. And then the other one has a positive 8. 1, 2, 3, 4, 5, 6, 7, 8. And then down 5. 2. Now I want to make sure. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's not the right spot. This is the right spot. So down 1, 2, 3, 4, 5, 6, 7, 8. Down 5. 3, 4, 5. Right 2. Down 5. Right 2. Then I'll go ahead and connect. Now what's this answer? So this is an estimate. It's not exactly on there. It looks like it's 1.5, so 1.5, comma, 4. It's kind of weird, but if I wanted to check that, again, I would put it into both of these original equations. Okay, so about to wrap up. I don't know if I'll actually do this one. In fact, probably not. So I'm not going to do this example, but what if I had x equals 4 and y equals 2? This is an equals. What's my answer? Now, right away, I'll tell you, is 4, 2. That's my answer. But we need to remember, anything that's a x equals a number, that's a vertical line. It goes up and down. And anything that's a y equals, well, that's a horizontal line. So if I have this system, I'm pretty happy because I'm just going to find x equals 4 and draw my line. And I'll find y equals 2. And I'll draw my line. So there's y equals 2. Pretty quick. And that's my answer. So what's that point? 4, 2. Which makes sense. I'm told x is 4 and I'm told y is 2, so x, y, easy. So we could have a situation where, for whatever reason, they're tough to graph, so I might have something like this. 4x equals 8y, and a system like y equals, and then maybe I have a 1 right here, plus, and an x. So sometimes they look funny. I'll divide by 8 here, and if I do, I'll get 4x over 8 equals y, and then I'm very tempted to write that as 2x equals y, but that's wrong. It's not 8 divide 4, it's 4 divide 8, so that's a half. And then this is flipped around, so I want to make sure I get it into slope-intercept form. Now, plus what? What's my y-intercept? Well, you might think, well, is it 1? Because of the earlier I said if it's not in front of the x, it's a 1. Well, it's a 0 because there's nothing there. Plus what? There's nothing there. So plus 0. So my y-intercept is 0, and then I'd use my slope of up 1 right 2. Okay, and that gives me plenty right there. Go ahead and solve that. And if I go to this previous problem, I'll subtract the 1. So there's no sign there, so it's assumed a plus. And I get x minus 1. So my y-intercept's negative 1. And then, well, what's my slope? Well, it's a 1, so up 1, right 1. And I see I get, and I won't use the line tool. Wow, that's really sloppy. See? It should have hit right there. And that answer would be 2, 1. And that would work for both of those. So one more example before wrapping this up, and that is, what if I have an inconsistent system? So maybe I have something like this, y equals 2x plus 3, and then I have this system, 2y equals 4x plus 10. So I solved this one for y. This one's already good. That one's set. Divide by 2, everything. So divide everything by 2. And I get 2x plus 5. Now notice I have the same slope, but different y-intercepts. So this is going to be an inconsistent system. You can tell that right away because these are going to be parallel lines. Parallel lines have the same slope, but if I go ahead and graph them, we'll quickly see that they are indeed parallel lines. So there's the first one. And then if I graph the second one with a y-intercept of 5, that's going to be right here. Oh, they're really close together, but they'll never actually meet. They're parallel lines. So that's an inconsistent system. Now, if I wanted a dependent system, instead of a 5 there would be a 3. And now they're exactly the same line, and that would be a dependent system. So we'll want to remember those 3 different situations that we could get. Consistent and independent, inconsistent dependent, and inconsistent dependent. All those different situations.